Hey, good morning and afternoon, geometry. We are going to work on 11.7, and it's a hard one to learn and it's a hard one to teach. So I will do my best and you have to do your best. It's about, we're going to do similar shapes and we're going to be writing ratios. So let's see if I think I have a screen where I have some words. Yep, we're going to talk about similar solids and write them into proportions and do scale factors. So I feel like I'm going to kind of bumble my way through this, but hopefully when we actually get to doing a couple of questions together, we'll be fine. Now, a heads up, I am going to do half of the problems that you are assigned on the video. So there's going to be 12 questions on your CAMI assignment. I'm going to do 6 of them on here. You still have to do them on your CAMI, but realize that you can always look back at the video to see how I did it if you had troubles. And then hopefully you can do the other 6 on your own. Okay, first we have to just talk about 3 different kind of dimensions. If I draw a line like this, I have an 8-inch line, or I'm calling it 8 inches. That's length. Notice the power. Let's do this. Let's get a number. What is that invisible power up here? It's an invisible 1. That means it's just length. We use length when we do perimeter. We use length when we measure a side. So I'm going to take that 8-inch line and I'm going to make myself a square. So it's 8 inches by 8 inches. Notice these are still to the power of 1. When I find out how many squares are inside, probably can't see that red line very well. Oh, I'm muddling up. I told you I'd muddle up and I am. I'd have to go 8 by 8. I'd get a different color. I'm just going to show you a little bit what I would do. Pretending I'm in class. When I'm in class, I don't get to just start over. So I have to have 8 lines across. 1, 2, 3, 4, 5, 6, 7, 8, and then 8 down. And if you counted up all the squares, you'd get 64 squares. Each would be an inch by an inch. But so area measures squares. Again, I drew all of these lines and got squares. 64 squares. Then we go to our third dimension, where we take an 8-inch, it's supposed to look like a square or a cube, 8 inches by 8 inches by 8 inches. And if I put blocks inside of there, you would multiply your base, 8 by 8, multiplied by your height, and you'd get 512 inches cubed. There it is. So we're going to be talking about cubes and squares and first power of things, and then we're going to look at shapes and we're going to try to do some scale factors. Back here, I want you to remember this. Scale factor, it's always to the power of 1. So kind of remember that. I had this table that I was going to have you see. I don't know if you're going to use this much, but if you need to, you can always look back. Realize, like, if I had a 4-inch line, made it into a square, there would be 16. To get 16, it was 4 times 4. If I put how many blocks would fit into that cube that's 4 by 4 by 4, it's 64. So you keep multiplying by 4. So this little 3 says multiply by 4 3 times. This little 2 says multiply by 4 by twice. And that 1 says multiply 4 once. Again, I'm not sure you need the table, but it's there if it helps. You know, if you have a side that's 8 by 8, you would know it's 64 and 512 like we did, or 7 would be 49 and 343. It's a reference table. This is a hard enough lesson to learn how to explain, so I think I'm best doing a problem for you. So it says, are the 2 figures similar? If they are, state the scale factor. To decide if they are similar, you have to write 2 ratios and see if it's a proportion. So you would say, I got to choose a good color here today. I'll choose purple. So right here, I can see this 50 centimeter line. There's a 10 centimeter line. Both of them are on the basis. So I could say 50 goes to 10. You can reduce it. We will reduce it in a moment. Now I'm going to compare the height ratio. That one's 100 and this one's 20. So I put the 100 over the 20. There's a number of ways you can do it. You could just, we need to know if they're equal. You could cross multiply on your calculator, or you could reduce first. If I reduce, it'd be 5 over 1, 5 over 1, that'll work. If you just cross multiply, you'd get 1,000 and 1,000. So yes, they are similar. The scale factor is the reduced ratio. And notice these are all to the power of 1. So that works for the scale factor. I'm going to do one more. I'm going to do number 2. Okay, this time I have 2 columns. So, got to write my scale factor. Okay, I have a diameter of 48. Uh-oh, I have a radius of 42. They're trying to mess with you. Don't let them mess with you. So change this one maybe to 24. Goes to 42. All right. Slant height, 48 goes to 96. So take your calculator. I think that's what I would do first. 24 divided by 42, or ABC. Oops, second. I hope you got 4 over 7. I was a little slow there. So try your 48 divided by 96, or ABC button. Uh-oh, 1 over 2. So are they similar? No. So the answer on this one is just simply no, because the ratios don't reduce to the same amount. So basically there's no scale factor on that one. Now you're going to do those 2 questions plus 2 more like that. Okay, let's get into these. This time it says each pair of figures is similar. So we know that the 2 ratios will be proportional. You have to find the scale factor of the left figure to the right figure, then find the ratio of the surface area and the ratio of the volumes. So first we do scale factor. So you can either choose the radii or you can choose the height. I look at my numbers and I think 90 over 60, that's my nicest numbers. Okay, to reduce that, some of you would know to do that. 9 over 6 reduces to 3 over 2. There's your scale factor. That's like the magic ratio that we're going to use. So now we have to find surface area. So area was squared. Remember that? So we have 3 over 2, but I have to square this ratio to get it to get it to area. So I square this 3. Imagine a little 2 up there. I get a 9. You have to square the 2. You get a 4. That's the ratio of area. Now I have to go to volume. To go to volume, you really can't go from area to volume. You have to go back to your scale factor and start from here. So you look at this 3, I'm pointing to the 3. And I have to get to volume. So that's 3 cubed. So I go 3 times 3 times 3. I'm going to kind of go back just for a second. 3 times 3 times 3 on volume would be the 27. So 27 on top. The bottom. Again, you got to go back to the scale factor to get to volume. You go 2 times 2 times 2, and you would get 8. That's your 3 answers. I think the trickiest part is you can't jump between area and volume. You always have to go back to the scale factor. Scale factor goes to area, scale factor goes to volume. You can't do this. No. I don't know if that looks like a no, but that's what I mean. Can't do that. You can only go from scale factor to area, scale factor to volume. Okay, let's go to the next question. Here we go. So you start with the scale factor. Now, if I chose height, that would be the 4 and 24. If I chose the length of this triangle, On the base, it'd be 9/54. In my world, 4/24 is the easiest. You must reduce it. 1/6. I like to circle the scale factor because that's the important one. Now I want to go to the area and then eventually the volume. So to go to area, I know I have to square it. 1 times 1, 1. 6 times 6, 36. You're done. That's the scale factor of the area. To go to volume, go back to scale factor. 1 times 1 times 1, still a 1. 6 times 6 times 6. I think it's 216. No, you heard me hesitate. So I could either go on my calculator and check, or I could go to my table. 6, 36, 216. There's your 3 answers. All right. Part of me thinks I should make this harder, and part of me thinks I should try to explain it better. It's kind of just a confusing lesson. It would be much easier to have you here for this one. Okay, some information about the surface area and the volume of the two similar figures, solids, has been given. Find the missing. So we're looking for a volume. Oh, they give us the surface area of the one. It's 4, I'm going to put yards squared, and that goes with the 25 yards squared. And they want to know the volume, which is 168 yards cubed over mystery. You cannot go from squared to cubed. You have to go back to scale factor, and you don't have a scale factor, so you have to work backwards. Again, you could use the table. Some of you would go back. I have a 4. We're in the middle column. You have to go left. The middle column, if it's a 4, square root of 4, is a 2. And you find the other number on there. Let's see. So the 4 becomes a 2. I'm guessing most of you know the 25. I could look back on the table. Square root of 25 is 5. There's the important one. So again, you cannot go from squared to cubed, but I can go from this one to that one. So I'm going to cube now I have to cube these two numbers. So 2, I have to take this scale factor and make it a volume thing. So I go 2 times 2 times 2. I'm going to write it below it. And I get 8. No, I should write it over here. 8. 5 times 5 times 5 would be 125. So to find this mystery thing, I have to use a cubic ratio. So I can go 8 over 125 equals 168 over x. Because this is a volume ratio and that's a volume ratio. You have to be in the same dimension when you're looking for something missing. So you take your calculator. 168 times 125, you get 21,000 equals 8x. Divide that great big number by 8. X will equal 2,625 yards cubed. Again, I told you it's hard to teach, and I felt like I was kind of talking in circles a little, but that's how you do that one. I'm going to do the next one. I'm going to have to erase this part because I went and put 2 things on the same page. So let me erase this. Get a bigger circle. It's kind of the same thing. We're going to have to find the scale factor, then we're going to have to cube the scale factor, and then we can write our ratio. Well, let's take a better color this time. Let's go green. So my area is 175 over 28. That's the scale factor of the areas. I have to back up and get the this scale factor over here. How do you do that? You have to take the square root of those two. And you know what? You don't know the square root of those two numbers, but there's a trick. Try reducing your fraction first if you don't know the square root of both numbers. So you go 175, ABC 28. And you would get, a 25 over 4. That's the one you want to use. Now we're still in area. To back it up to its scale factor, you take the square root of those two numbers. Look, because these are squared. Square root of 25 is 5. The square root of 4 is 2. There's my important square root, or my scale factor, sorry. I have to find the volume scale factor. So I go 5 times 5 times 5, I get 125. 2 times 2 times 2, I get 8. This is the volume scale factor, 125 over 8. I can use that when I put 3,500 over x. Now I can cross multiply. And divide by 125, and you'd get 224 yards or kilometers. Let's fix that a little bit. 224 kilometers cubed. Again, it's not necessarily difficult, but you can walk yourself in a circle. You have to be careful of the powers. These are squareds. We had to take it down to the power of 1. Then we had to take it back to the power of 3 so we could do an equation with the power of 3. Okay, that's 8. That's 6. 6 of your questions. You're going to do 12, but you can always look back at these 6 because they are part of your assignment. Hope it goes well. Let us know if you're having troubles. We'll talk you through it.